Hello, in this question 41, N-type semiconductor. N-type semiconductor. The following statement is true. In N-type, majority carrier is electron. Ne concentration of electron very large than hole concentration. So holes will be minority here and electrons are majority. So here in N type Ne is more than NH. In P type NH is more than Ne. So option here is 3. It is correct. Hello, probability of electrons in the conduction band, valency band at fixed temperature, finite temperature. Electrons are jumping to conduction band. Say band gap increases and probability of electrons availability in conduction band decreases exponentially like this. Is the energy gap and availability of electrons in conduction band decrease. So option 2 is correct. Hello. In this question 43, small amount of antimony. Normally doping is purity atom added to the pure semiconductor, maybe germanium, maybe silicon, a very small amount, in the ratio 1 is to 10 power 6 per 8, 10 power 10. Only one atom is sufficient in millions of a pure silicon or germanium crystal. But arrangement is like this. Antimony is replacing the germanium atom in such a way so it is creating the extra electrons after 4 covalent bonds. After making the covalent bond, electrons act like free in the crystal, so it will be N-type semiconductor. Option is correct. Here Ne is much more than NH. Concentration of electrons, free electrons is much more than concentration volts. Option 3. In question 44, in half wave rectifier, frequency of input AC is the frequency of output DC. So frequency remains the same in and half wave rectifier. So option 2 is correct. In full wave, frequency will be double. Hello, in this question, piece of copper and germanium conductor, and germanium is semiconductor. It is cooled down to 77, means temperature is decreasing here 277 Kelvin, then copper strip resistance decreases and for germanium resistance increases. Option 45 and 3 is correct. Here in this question, in the depletion region, ions are there which are immobile. 2 negative. There's no mobile charges. Mobile charges comes here, holes and electrons, they will diffuse. So there's no mobile charges in the depletion region. Means option 1 is correct. In this question 47, for conductor, electrons are mostly available in conduction band, so their conducting energy gap is between the conduction band and the valence band is approximately 0. So option 4 is correct. Hello, in this question is the distance given 4 into 10 to power minus 8. This distance energy increases. So using the third equation, V square is equal to 0 plus 2, A means 1 M into S and D. So kinetic energy equal to what? Half M V square 2 QE means electron here. So this is 2 cancel out, M cancel out, given E into A, force into this. And kinetic energy is given 2 electron volt. So here 2 electron volt out E, so will be divided by 4 into 10 power minus 8. This will be 2 10 power 8, or you can write like this also. Electrical field is 5 10 power 7. Option here is 2 correct. This question, energy gap for carbon roughly 5.6 volt for carbon, and for silicon germanium 0.7. Means here maximum for carbon. So this maximum and this. So option 3 is correct. Option 3 correct. Hello, in this question, let us say formation of p-n junction diode, n region here and with. Here holes are there, electrons are there. So due to the attraction force, holes are moving towards N side and electrons towards P side. And these are the majority carriers. And because of this, what will happen? Side positive immobile carriers, ions, negative ions developed, and because of this voltage barrier or electrical field barrier developed here from N region to P region. So barrier voltage developed the majority carriers in N junction diode, holes and electrons. It means option 2 is correct. Question: dynamic resistance in forward biasing is the change in voltage on change in current. 5 milliampere. Solve it here. Like 5 cancel out 10 power minus 10 ohm. So option 3 is correct. So in this question, input maximum voltage given as 220 RMS multiplied by root 2, and in half wave rectifier, the output DC given as maximum voltage divided by 2. So this is 110 2 volts. Then 3 is correct. Hello, in this question, we know this is N junction diode, P N junction diode, and this is the depletion with. Here this is the voltage positive, negative, barrier voltage, and this is the barrier electrical field in this direction. Conduct it reverse biasing like this. So this is the voltage applied in reverse biasing, and this barrier voltage, they are added up, and electrical field is supported barrier, and this is the electrical field due to the supply voltage. It means here strong electrical field will be there, the barrier and the applied voltage. So this is stronger, and velocity increases. The region behind here is doping concentration fall, then the chances are there to move for a longer time. So speed increases and electrical field also increases if the concentration is. Means option here 1 is also correct and 4 is also correct. So there are two options. Hello, in this question, holes. Holes are the charge carriers in intrinsic also and p-type also. In n-type semiconductor, electrons are dominating. In p-type, in extrinsic, p-type is given or developed by the impurity from the trivalent. Then p-type semiconductors, and its hole concentration is much more than electron concentration. And in intrinsic, both types of there. Electrons, intrinsic semiconductors, holes as well as electron concentration are equal. So in intrinsic pure type, holes are available. In p type, holes are available in plenty, but n type, electrons are more. So option 3 is correct. In this question, unbiased means there's no forward or reverse biasing. Here in P region, holes are more and more, N region electrons are more. Say holes move from N and electrons move in opposite direction. So option 3. In diffusion, holes move from P to N, electrons in opposite direction. Here we are talking about holes. So it is true, then it is correct. Hello, in this question, energy gap is H by lambda in joules, and it by dividing this E electron charge, this is electron volt. So H 6.62 per minus 34, the speed of light lambda 2480 nanometer, and charge on electron. Calculate it coming here 4989 roughly 0.5 electron volt. So option is correct. Or directly we can find is 1240 divided by wavelength in meter. So coming roughly 0.5 volt. So option is correct. Hello, in this question, ripple means the AC part in the output to DC of rectifier. This is called a ripple factor. Ripple factor in half wave is quite high, whereas in full wave rectifier it's lower, 0.48 roughly in percentage. So option 3 is just learn करना है. Hello, in this question 9, it is 1 ppm means particle per n. So here antimony, the dopant belonging to a 15 group pentavalent. So it is giving the electron the intrinsic shell. Here concentration of electron 5 into 10 to the power 8 per million per 6. So 5 into 10 to the power 22 per meter cube. And if concentration of holes 4.5 into 10 to the power 9 per meter cube, then Ni intrinsic concentration square equal to NH, or Ni will be root of Ne NH. Put it here. Ne means 5 into 10 to the power 22 whole concentration 4.5 into 10 to the power 9. After solving, it is coming 1.5 into 10 to the power 16 per meter cube. Intrinsic means pure semiconductor. Here option correct. Hello, in this question, N-type semiconductor, this is conduction band and valency band. The gap between them, valency and conduction band, is 1.1 electron volts for silicon and 0.72 for germanium. But if we add the doping by pentavalent donor atoms, so here donor energy is set just below the conduction band by a smaller gap 0.01 electron volt. That is why much 0.01 electron volt energy is sufficient here to jump the electrons from this level, donor energy level, to the conduction band. Have to learn it. So option here is 4. So in this question we know NH Ne equal to Ni square. Hole concentration, electron concentration, and Ni means intrinsic concentration. Here we have to find the Ne, electron concentration, is given by this. So here Ni is given 1.2 into 10 to the power 15 square, that's why 1.2 into 10 to the power 15 upon whole concentration 4 into 10 to the power 20. Solve it here, comes 3.6 into 10 to the power 9 is the electron concentration. So option 3 is. Hello, in this question also the same thing. Hello, here Ne equal to Ni square upon NH, which is given here. This is 4.5 into 10 to the power 22 whole concentration, and intrinsic means 1.5 into 10 to the power 16. Solving here, Ne comes here 5 into 10 to the power 9 per meter cube. Option 3 is correct. This question here, the diode barrier voltage is 0.7 volts, and the battery voltage here is only 0.5 volts. Means this is not sufficient to overcome the barrier voltage. That is why this circuit having diode is now reverse bias, and as it is the reverse bias, it is not allowing the current to flow in the circuit. Means all the voltage, battery voltage, is coming across this diode, and current will be, there is no current in reverse biasing. Option 2 is correct.